Geometry students do the mid-chapter review, page 77, numbers 1 through 20. Let's jump into this and let's see if we can't review a lot of information. Okay? Please pay attention, work hard, and do this from your heart, really trying to learn. Numbers 1 through 6, the directions say to complete the statement. Okay? Point A is called the what of ray AB. Now I know that AB is a ray because of the symbol right here. Okay, the symbol right here. So I have ray AB. So because A comes first, A is here. And here's my ray. Now, the ray does not have to point this direction like this ray. It can point this direction. But A would still be right here. Okay? So both of these are ray AB. What do we call point A? It's called the initial point. Initial point. And it's called that because initial means the beginning or the starting. And this is your initial or beginning or starting point. So point A is called your initial point. Number 2. Points A and B are the blank of. Now look at your symbol. This is a segment symbol. So we have segment AB. Segment AB. So what do we call points A and B? Well, they're called the endpoints. Are they not, students? The endpoints. Okay. So points A and B are called the endpoints. Okay, moving on to number 3. Now, UV equals XY. So if UV equals XY, and by the way, I don't really care for this problem because they should give us more information. To be honest with you, they should tell us whether we have a segment or what we have here. Okay, but anyways, UV equals XY. They're the same length. Then what do we know about UV and XY? Well, if they're equal, they are also congruent. Okay, so they're congruent. Get used to that word, congruent, and that symbol. We're going to use it a lot. Okay, number 4. If S is between R and T, then the ray opposite SR is blank. Now here we go. S is between R and T. And notice we have ray SR. Let's go over this again for the 3rd time. S is between R and T, and SR is a ray. So here's S. Here's R. There's my ray. Now remember, in geometry, when we say a point is in between 2 points, that means those points are collinear. In other words, they lie on the same line. Please don't forget that. Whenever a point is said to be between 2 other points, then you're allowed to assume that all 3 points are collinear. So with that in mind, SR is a ray. S is between R and T. So if S is between R and T, here's R. T has to be over here somewhere. Okay. So here's what they're asking. The ray opposite ray SR is what ray? Well, guys, think about it. If this is SR right here, ray SR, what ray is opposite that? I better put T here. What ray is opposite that ray? This ray here. They're going opposite directions. So ray ST. Please do not put ray TS. The initial point is here. The ending point is here. So it's called ray ST. Ray ST. Alright, moving on to number 5. C is in the interior of angle DOE. So let's go ahead and draw angle DOE very quickly. D. It's so helpful, guys, to take the words they give you and draw a picture. It's so helpful. C is in the interior. Now, it doesn't matter where you put C. Put C wherever you want to. I'm going to put it there. Alright. Now, how do I know to draw a line or a ray, whatever, coming through here? Because of this right here. It says angle DOC. See it right here? Angle DOC. So there has to be a line drawn. Now look what it says. Angle DOC. This angle here plus an angle. Well, that's this angle here, guys, equals the entire angle right here. Come on, think. Let's give some numbers to these. Let's call this angle 1. Let's call this angle 2. And we'll call the entire angle angle 3. Okay? Now, it's obvious angle 1, this angle here, plus this angle here, add them together and you get the whole angle. So, angle DOC, this angle here, DOC, plus angle COE, COE, equals angle, this angle plus this angle equals the entire angle DOE. And even though the answer is not up here, that is the correct answer. So angle COE plus angle DOC equals the entire angle DOE. That's called the angle addition postulate. Number 6. JK bisects angle HJI. So here's angle HJI. HJI. JK bisects it, so I'm going to draw JK, cutting this angle right in half the best that I can, okay? Alright, now, so here's my big angle, HJI, the big angle being bisected by JK here. Now, if JK is bisecting this big angle, that means it's cutting it in half. So if it's cutting it in half, then that means that this angle right here is going to be congruent to this angle here. So angle HJK, HJK is congruent to what angle? KJI, or you can call it angle IJK. Either one is fine. Pretty simple. Alright, now for numbers 7 through 12, we're going to use these directions right here. Okay, we're going to be really careful and draw a picture, and then I'll kind of copy that picture and use it over and over. Okay, so here we go. The directions read in exercises 7 through 12. Point M is between points L and N. So it looks like we need a coordinate plane, doesn't it? So I'm going to draw a really small coordinate plane here. I don't need that many tick marks. I'll put 3 here, 3 here, 3 here, and 4 here. Just kidding, 3. Now, point L, negative 2, 0 goes right here. That's point L. 3, 0 goes right here. And that's point N, okay? M is between those points. I don't know where M is. We'll just throw it on here somewhere. But I know this. KML is obtuse. So wherever I put M, let's just put M right here because I feel like it. Okay, no big deal. There. M is between these points. Okay? Now, notice KML is obtuse. You say, Mr. Earhart, I don't see K. I don't either. Let's put it up there. Now I could put K right here. But if I do that, look at angle KML. KML. Does that angle look obtuse to you? No, it looks smaller than 90, doesn't it? So look, they tell you KML right here is an obtuse angle. So you've got to put K somewhere over here like this. There we go. Now KML is obtuse. Is that true? Yes, it is. So, let's answer the first question. I think I've taken all this information here the best that we can, and we've put it onto a picture right here. So, question number 7. Is angle KMN acute? Well, here's K. M, N. Is it acute? Most definitely, it has to be. If this angle here is obtuse, then this angle here has to be acute. Most definitely, okay? So the answer is yes. Okay? Or is the angle acute or obtuse? The answer is acute. Alright? Alright, let's copy this picture so we can continue to use it if we need to. Alright, moving on to number 8. Is point M the this segment here, then yes, M is the midpoint of LN. But we don't know that for sure. Now I think they put if, well, okay, they didn't put anything on it, but I would answer it. Here's how I would have answered this. On a test or a quiz, I would say, is point M the midpoint? I wouldn't say no, it might be. I wouldn't say yes, it might not be. I would put not enough information or can't be determined. Okay, because we really don't know. Alright? Or you could say yes it is. Yes, it's the midpoint if LM is congruent to MN. Alright, moving on to number 9. What is LN? What is LN? Well, LN is a segment, I would think. I'm not sure. Oh, what is the length of LN? I believe, yes. Okay, they want to know the length of LN. Okay, no problem. Let's get our pen out here. Put your pen on L right here. Okay, and then don't count. Don't count until you move your pen. So you put your pen here and then move it. 1, 2, 3, 4, 5. Or you can start here if you want to. And do not count until you've moved your pen, okay? So your pen's here. 1, 2, 3, 4, 5. So the length of LN is... Okay, why is this not working? Something's not right here. Alright, let me get out my mouse here. Maybe that'll work. Alright, there we go. Alright, so what is the length of LN? The length of LN is 5. Okay. Alright, moving on to number 10. Name 3 collinear points. In other words, name 3 points that lie on the same segment or the same line. Well, guys, that's pretty easy. What 3 points do you see lying on the same line? L, M, and N are collinear points. So L, M, and N. Alright, number 11. Write the segment addition postulate for LN. Alright, this will be good. Let's pay attention, okay? I want you to write the segment addition postulate for LN. So here's LN right here. And M is somewhere here in between. We'll put it here. Now, what's the segment addition postulate? Well, guys, come on. It's not that difficult. We should know this. Segment LM plus segment MN equals the entire segment LN. Okay? That's the segment addition postulate. This segment here plus this segment here equals the entire segment. Alright, number 12. Which of the angles is a straight angle? Well, guys, look, here's a straight angle right here, but M's in the middle, okay? So we're going to have to call it angle LMN or angle NML. You cannot get those out of order. This is a straight angle right here, okay? We have M right here. We have N right here. L right here. That's a straight angle. Just go like this. Put a little arrow here, a little arrow here. And so we call that angle LMN or angle. I don't know why I keep drawing that at M. Angle LMN or angle NML. And here it is. LMN. Alright. Okay. Moving on to numbers 13 through 16. We're just going to answer the questions. Find BC if AB equals 12 and AB is congruent to BC. Now, guys, that's so easy. Look at this, please. AB is congruent to BC. That means AB equals BC. Got it? How big is AB? 12. So how big does BC have to be? 12. They're equal. So the answer is 12. Number 14. Find the measure of angle COE if COE and EOF are congruent and OE bisects the right angle COF. So I know I've got a right angle. Okay, there's my right angle. It's right angle COF. So COF. Got it. Now, OE bisects this right angle, so I'm going to cut it right in half. the best that I can, okay? So OE bisects the right angle. Now, find the measure of angle COE. Well, guys, come on, think about it. OE bisects the right angle, okay? So here's the right angle right here. This ray cuts it in half. We know this whole angle here is how big it's a right angle, 90 degrees. So OE cuts it in half. That just simply means this angle here is how big, 45, and this angle here is how big, 45. So find the measure of angle COE. Well, here's C down to O, up to E. What's the measure of angle COE? 45 degrees. Alright, moving on to number 15. Find the distance between E and F if E is this ordered pair and F is this ordered pair. Now, guys, you have learned how to find the distance between 2 points because you've been given the distance formula. Alright? X minus X quantity squared plus Y minus Y quantity squared. And the square root of all of this, okay? So here we go. This is your X, this is your Y, this is your X, this is your Y. So we're going to take X minus X in this parentheses. Well, my X numbers are 3 and negative 1. 3 and negative 1. So 3 minus a negative 1. 3 minus a negative 1 plus, now I've got Y minus Y, so I'm looking for two Y numbers. My Y number is 4 and my Y number is 2. 4 and 2. So 4 minus 2. Alright, if you struggle with your sign numbers, feel free to use a calculator. 3 minus a negative 1 means 3 plus 1, which is 4. So you really have 4 squared. Plus 4 minus 2 is 2. You really have 2 squared. So next we have 4 times 4 is 16. 2 times 2 is 4. 16 plus 4 is 20. So the answer is the square root of 20. Square root of 20. Alright? Okay, continuing on to number 16. Find the length of ST if OR bisects ST at M and MT is 11. Wow, that's confusing. Okay, let's take our time and work our way through this, okay? Here we go. Find the length of ST. So I know I'm going to have a segment that has ST on it, okay? OR bisects ST. Look at this, guys, really carefully. Ray OR bisects ST at M. So I know if it bisects ST, it cuts ST in half. If it cuts ST in half, that means M is going to be right here in the middle. OR, ray OR bisects ST. So I'm going to draw a ray like this. There's a ray. You can draw yours however you want to. I'm drawing mine like this. There's my ray, and it's ray what? OR. So put an O here and an R here. By the way, this ray can be called ray OM or it can be called ray OR. That would be the same ray. Okay, it does not matter about which letter you use as long as you have your end point here that you start with. Okay, so let's see what I've got so far. I've got segment ST. Ray OR is bisecting at M, and then we know MT is 11. So from M right here all the way down to T right here, the distance is 11. Now hold it. We know that OR cuts ST in half. So if ST is cut in half, that means if MT is 11, SM from here to here must also be 11. So what's the entire length of ST, which is what they want us to find? Find the length of ST. Obviously it's going to be 22. 11 plus 11. Okay? Alright, moving on to number 17 through 20. You can look in your book if you want to. The directions say you are designing a sail as shown below. You design the sail. Now I'm going to write on this here. So that OB bisects AOC. So that means this angle here is congruent to this angle here, okay? Because OB, it says right here, OB cuts or bisects AOC, and here's AOC. Okay, so I know these two little angles right here, this angle is congruent to this angle here. Alright, now, let's see. AOD is 45 degrees, so I'm going to put that in here. And angle BOE is a right angle. Okay? So BOE from here to here is a right angle. Got it? Now come on guys, look over here. Think this through. If you know this is a right angle here, what does this have to be right over here also? A right angle. So if BOE, this whole angle here is a right angle, then you know that means this angle right here is also a right angle. Got it? Now, please watch this carefully. If this angle right here is a right angle, and this angle right here is 45 degrees right here, then this angle here must also be what? 45 degrees, because these two angles together are supposed to add up to 90. Okay? Now, remember at the very beginning I said, this angle right here is congruent to this angle here. So if that's 45 and they're congruent, then this has to be 45. Now remember what it says here. BOE is a right angle. BOE. This whole angle here is a right angle, okay? So if that's the case, and this is 45 degrees here, then this has to be 45 degrees also, because 45 plus 40 is 90. Alright, here we go. Question number 1. Name the 3 sets of perpendicular rays. Perpendicular rays. Well, I know that DOB right here, that angle's a right angle, so I've got 45 plus 45, so they're perpendicular, okay? So I would say rays OD, into OB. Okay, that's one set. Now, look at this. Angle AOC. That angle right there has to be 90 degrees, because this is 45 and this is 45. So that whole angle there has to be 90. So if that's the case, then that tells us that this line here and this line here are perpendicular. So those rays would be called what? Ray OA and ray OC. So OA, comma OC. And then lastly, here's a right angle right here. There, going over to there, because these two angles add up to 90. Plus they tell us right here, BOA is a right angle. Okay, so with that in mind, that means BO is perpendicular to OE. So my perpendicular rays would be, let's see, this one here should be OC. There we go. OAOC. The next set should be OB. This ray here into OE. Alright, let's see how we did. Okay, down below, but I can look in the book here and see that we are accurate. The only thing I did wrong was I should have done this, and I really should get in the practice of doing that. To set a good example, you should put your symbolism on there. Alright, okay, moving on to number 18. Which postulate allows you to conclude? Now watch this. If you add angle AOB, so this angle here, plus angle BOE, so this whole angle here, alright? So you add this angle here, plus this angle here, and it equals this whole angle right here, AOE. So in other words, this angle here, plus this angle here, equals this entire angle here. We call that angle addition, the angle addition postulate, okay? Now they said in number 19 to use an equation given in exercise 18. I'm not going to do that. They just simply are asking us to find the measure of angle AOB, and we already did that. AOB is 45 degrees, okay? 45 degrees. Lastly, name 4 congruent acute angles, okay? Angle DOA. This angle here is 45 degrees. Angle AOB. Angle BOC. And angle COE really should write it like this, to be honest with you. Angle DOA is congruent to angle AOB, which is congruent to angle BOC, which is congruent to angle COE. That's really how you should write it. Okay, so there you go. I hope this mid-chapter review has been a good review. If you have any questions, don't hesitate to call or email.